Pay attention to this.
We're happy to work on these. Finally. And we're also really looking for, to really bring in these additional strains in order to work towards a pangenomic view of all of these species. So this is really following the work that we're doing in the Human Pangenome Reference Consortium, but also a lot of the work that's being done in agriculture and crops. But we're also working through projects such as the Darwin Tree of Life to annotate all eukaryotic species around the world. So in the UK, for example, we are sequencing, working with partners across the UK to sequence and annotate all eukaryotic species, including those in the territorial waters. So this would bring in huge potential for new genetic targets that you can bring in for future genome editing. So as well as the gene annotation, we also provide a range of other annotation aspects. We have comparative genomics, variation, and regulatory elements. So in terms of our comparative genomics, we're regularly producing large comparisons across a huge number of aquatic species, generating genome alignments, gene family trees, and also inferring homologs from across the different species. So here you can see an example of gene PRKG1A, focusing in on the turbot and showing this gene family in detail. This is fully explorable and expandable, so you can look around and really explore the depth of the comparative genomics of this particular gene. There were two quite detailed talks on the regulatory build for ENSEMBL on Wednesday, so I won't go into much detail on this, but really just to say that we're taking the wealth of aquatic AQUA-FAANG data that we've had from both the TAC-seq and SHIP-seq data, and using this for the first time to produce regulatory builds in aquatic species. In the past, ENSEMBL has only done this for human and mouse. And so there's already available these for open chromatin reasons for salmon, sea bass, and turbot, which came out earlier this year. But in November, we'll be releasing 2 further species, but then also having our predictions for promoters and enhancers as well. So this data is coming out and available through the browser in around November. And in terms of variation, we also annotate variants from data available from the European Variation Archive, and wherever possible, we'll also associate this with disease and phenotype information. So you can also, for each of these AQUA-FAANG species and for a variety of other aquatic organisms, you can also access a huge array of variant information that we have available from publicly available information, drawing in data from all across the world. These have the molecular consequence of the variant and each overlapping transcript whenever this is predicted. So you can see, for example, this is a missense variant. We do population allele level frequencies when this information is available. These are calculated from all of the genotype data that's held within the European Variation Archive. You as industry partners will probably do something very similar on your own populations within your data, but we obviously can do this from all of the publicly available information that we hold. We also do linkage disequilibrium calculated at the population level, and we'll present this alongside the gene information. And then one of the key things that we have is this variant effect predictor tool, which is actually really allowing you to take the variants and the transcripts and regulatory features that you have and then predict their molecular consequence from the genomic information that we hold. And then we'll also then report this back as a range of different sequence ontology terms for you to interpret your own variants against the wealth of data that we hold within our archives. So you can access the tool. It's freely available for industry and for academic use. So it can quickly analyze a huge different array of GWAS top hits that you have. You can do this on a single one, or you can upload a maximum job size of a 50 million file. It is managed by a scheduling system, so if you do a large file, it can take some use, but we've really designed this to be as simple to use and configurable as possible. And there is a large amount of training available on the web for you to sort of train you how to use it and get the most out of this system. So once you use this, it will provide an output such as this. You'll be able to actually link into the specific region that this is targeted. It will show you the transcripts. Then whenever possible, it will also then show you also if it's got a protein hit, it will move out to our UniProt database, which is our protein database that we have at EBI, and also show you the information there. And you can see in the second column, it's predicted the consequence of this variant that it's had on the reference genome. So for this, we'll also provide summary statistics. So if you provided a large batch of variants all at once, we'll provide statistics over that batch. And then we'll also provide filtering. So if you're looking for particular missense variations, for example, you can filter through a very large number of variants and find the ones that you're very, very much interested in. So I won't go into huge detail here. The really important one is the top line for the industry partners, which is you can run this locally behind your own firewall. So if you want to run this and have absolute assurance that no one is going to see what you're doing and which variants you're uploading to this, then this is the best option for you. We've again tried to make this as configurable and easy for you to use as possible, but there's a huge amount of training available to support you in how to do this. So it really allows you to integrate your own private and custom files that you have, and then access the wealth of data that we have in our archives in order to make these predictions. So as I've said, this is really a whirlwind tour of what's available in ENSEMBL, and this is a tool that can take some time to get used to, but we have a huge array of training material available, both web-based, but also in-person training that runs through the year, both virtually over Zoom and in person at various conferences and events throughout the year. So we have a dedicated team of training specialists that do this, and they will also, if you request, they will come to a particular conference and run training events at that conference if you wish. I also wanted to highlight that we have an industry program and consultancy. So our industry program provides direct contact between industry partners and our institutes to really inform you of our future directions and allow you to influence what we're doing. We have these strategy meetings and expert level workshops for industry partners that really are on different topics to sort of really allow you to direct what we're doing within the institute. We also have a commercial arm, so if you do have something specifically wanting us to work on, we are able to work in a consultancy way in order to support industry members on aspects they do. But the majority of our work is done openly for the scientific community. So really, I just wanted to highlight that we have this huge array of freely available services and tools for genomic interpretation, and AQUA-FAANG has really made this possible to have these really high-quality annotations, both the transcriptomic gene annotations, but also the regulatory and variant annotations for these key AQUA-FAANG species. And we will continue to work on these species. We'll continue to load new telomere-to-telomere references when they become available, and really interested in getting as many different strains loaded as possible so that we can improve our variant prediction and give you as much variation possible for the future of genome editing. So I just want to highlight this as a huge team of people that work on ENSEMBL, so I won't be able to name them all, but I'll particularly highlight that we have Garth and Gabriella in the audience today, who are regulatory specialists, but I'll also highlight Fergal and Leanne, who are the main people that worked on the gene annotation for the 6 AQUA-FAANG species.